So you can see you've got a little bit of flexibility there. Just turn off this feature and we'll move on to location. Now, location is very important, as this flyout actually allows you to choose how the particles are distributed on the source icon. There are actually 5 options, and they are pivot, vertices, edges, surface and volume. And you can actually use a combination of these 5 options and the actual options of the shape of the icon to determine how your particles are going to be distributed into your scene. So let's have a look at sphere. We'll use this as an example. You can see that at the moment we're using surface. So if I move the timeline along until the particles are distributed, I'll just put it here so that actually the icon hasn't moved yet. And we can move in and have a look, and you can see that the actual particles are actually on the surface of our sphere icon. Now, the next option is volume. And you can see quite obviously the particles have now moved so that they're inside the volume of the sphere. So that's pretty intuitive. Let's have a look at edges. Now you can see with edges, the particles have actually been positioned based on the actual wireframe edges that you can see in the icon. Now, with vertices, you can see that the actual vertices that are used to create these icons, they actually determine the position of our particles. Now, we have actually got 400 particles emitted here, but there are actually only 6 vertices in this particular icon. So you can only actually see 6 particles. Although, of course, each particle position has multiple particles in it. They're just all stacked up on top of each other. And the last option, which is also quite obvious and doesn't really vary for each icon type, is pivot. And in this case, the particles are emitted and then positioned at the pivot of the icon. So if I change the icon type to rectangle or box or circle, there's no change with that particular option because the pivot's always in the same place. So let's change the type back to surface again. And you can see with the disk you get the particles on the surface of the disk. Or you can see if I change to volume, they appear within the volume of the disk. And in this case, there's no actual volume to the disk, so there's no real change in the distribution. If we change to an icon that actually has some volume, let's say to a cube with box, you can see that the particles are now distributed on the surface. This is the same as with the sphere icon. And again, if I change to volume, you can see the particles are distributed inside the volume. So you see, you've actually got quite a bit of flexibility in the way you can actually distribute your particles around the icon. It's not as simple as it being, you know, just based on the surface or the pivot. You've got those different options, and you know, it's quite flexible when combined with the different icon types as well. Now, the distinct points checkbox will limit the amount of position points to the value in the total spinner. In this case, you can see it's set to 10. So you can see that we're currently using volume, and now we can only actually distribute our particles to 10 distinct points within the volume. If I change to surface, you can see it's only allowed to distribute the particles to 10 distinct points on the surface. This makes a lot of sense. Now, if I was to change the type to vertices, this particular object only has 8 vertices. So in this case, using distinct points really doesn't make that much sense unless it's a value which is below 8. In which case, it'll actually limit the distribution points to one, you know, to a division of the corners. You know, if you choose 6, it'll only appear on 6 of the corners and so forth. So distinct points is useful when you want to create, for instance, streams of smoke or water dripping from a surface. By using distinct points, you actually get a stream of particles appearing from one particular place or 10 particular places on the surface. So in that way, you can actually restrict the distribution of your particles over the icon. As with the birth operators, you can actually distribute your particles over the object on only at frames. And this can cause the same kind of issues as actually using the birth operator with subframe sampling turned off. So you're given the same option here. You can actually turn on subframe sampling, and that means that the particle positions can actually be assigned to the particles over the duration of an entire frame, not just at the frame end. And this means you won't get any kind of puffing in the position of your particle positions. Finally, we have uniqueness, and this is used for your total points. If you choose 10 distinct points, let's say, and then you change this seed value, you will get another 10 distinct points. Particle flow will generate another 10 distinct points. So it's the same as other uniqueness values. This basically just randomizes your the seed of your random function and can then change the distribution of your particles. So there you go, that's position icon. It's a very basic operator. It's one of the fundamental operators that you'll see, and it's part of the standard particle flow. So let's move on to a little bit more flexible an operator now, and that is the position object operator. When you need more complex distribution of your particles, or you need them to appear on a certain surface, you'll need to use the position object operator. This operator is used a great deal in production, so it's well worth becoming very familiar with it. It offers quite a few options, so it can take a little getting used to, but it's well worth it. So let's have a look at it.